Hello, in this video we're going to talk about the laws of exponents, and we're going to start off with some powers of 2 and some basic powers of 2 to justify the rules to you. So just as a reminder, 2 to the first is simply 2. 2 squared means 2 times 2, which is 4. 2 cubed means 2 times 2 times 2, or 2 times itself 3 times. And that's the same thing as 2 squared times another 2. 4 times 2 is 8. 2 to the fourth would be 8 times 2, which is 16. 2 to the fifth would be 16 times 2, which is 32. 2 to the sixth is 64. 32 times 2. And 2 to the seventh is going to be 64 times 2, which is 128. And bringing up those powers of 2 to justify the laws of exponents to you, and hopefully that'll help them make more sense. Now, the first rule we're going to look at is what I call the power rule. The power rule is this one. It says when you have x raised to the n power, and then it's also raised to the nth power, then with exponents like this, you multiply them. To justify that, consider this statement. 8 squared is 64. Well, 8 times 8 is 64. Now, if we look at this from an exponential point of view, 8 is 2 to the third. So 2 cubed raised to the second power is going to be the same thing as 8 squared. And we know from our previous chart that 64 is 2 to the 6. Now, what I'd like you to do is look at this 3, look at this 2, and look at this 6. How can we get 6 out of this 3 and this 2? We do it with multiplication. And that's what the power rule tells us. Also, another thing to notice is all the bases are the same in these. Okay? The next rule is multiplication of bases. If you have x to the m times x to the n, well, we say that's equal to x to the m plus n. So in other words, when you have an expression that looks like this, same base, then you add the exponents to multiply the bases together. Number point of view, exponential point of view. If you consider 8 times 4, well, we know 8 times 4 is 32. Now, if we consider this equation from an exponential point of view, 8 is 2 to the third power. 4 is 2 squared. And we know that 32 is 2 to the fifth. So what you need to do now is look at this 3, look at this 2, look at this 5. How can you get 5 out of this 3 and this 2? Well, with addition. 2 plus 3 is 5. And that's our justification for that rule. Now, it should make sense to you that if you're going to multiply two bases together, the same base, then you add the exponents. Okay, so what follows out of that is if you're going to divide the same base by another same base, then you're going to subtract the exponents. And in fact, that is what we do. The third rule is x to the m divided by x to the n is going to be x to the m minus n. Once again, from a numerical point of view, a number of fact is 32 divided by 4 is 8. Now, if we consider this equation from an exponential point of view, 32 is 2 to the fifth, 4 is 2 squared, 8 is 2 to the third. Look at this 5, look at this exponent of 2, look at this exponent of 3. How can we get 3 out of this 5 and this 2? Well, you can get it by subtraction. Then, the zero rule. Any non-zero number to the zeroth power is 1. Kind of weird, but it works. Also, I should point out that in this rule, this works as long as x is not equal to 0. If your base is 0, we don't know what the heck this is. Remember, division by 0 is illegal in Oklahoma, and pretty much everywhere else too. Now, our fourth rule, x to the 0 is 1. Well, once again, numerical fact, 8 divided by 8 is equal to 1. Matter of fact, any number over itself except 0 is equal to 1. 8 is 2 cubed, so I wrote this as 2 cubed over 2 cubed. And following this rule, you know to subtract the exponents. 3 minus 3 is 0. So that means that 2 to the 0 has to be equal to 1. And then our fifth rule, the last one we're going to look at in this video, is what I call the position rule. Now, you need to keep in mind, that the sign of the base, whether the base is positive or negative, that means position on the number line. Is it on the left-hand side of 0 or the right-hand side of 0? But the sign of the exponent means position in the fraction. If you have a negative exponent, then that base is not at home wherever it is in the fraction. If you have a negative exponent in the top or the numerator, then you need to send it to the denominator. And when you move an exponent around in an expression from the top to the bottom, or from the bottom to the top, from the numerator to the denominator, or from the denominator to the numerator, only thing that changes is the sign of the exponent. Okay, you're not changing its position on the number line, you're changing its position in the fraction. Now, this rule says that when you have x to the negative n power, that's the same thing as 1 over x to the n. That's what I mean. The only thing that changes here is the sign of the exponent. Now, consider this expression. We know that 8 over 16 reduces down to 1/2. You can divide the top and the bottom both by a common factor of 8. We also know that 8 is 2 cubed, 16 is 2 to the 4th. And we know from our division rule that with exponents like this, we subtract them. So that gives you 2 to the 3 minus 4 power. And 3 minus 4 is negative 1. So that means that 2 to the negative 1 is equal to 1/2. Okay? All right. That is the laws of exponents. This is one of those things that just isn't going to go away. We're going to see this again and again and again and yet again. So, y'all need to pull a George Strait thing on this and write this down. Make a tape recording of it, stick it under your pillow at night, but you need to know the laws of exponents. Good luck. Go do some math. Thank you.